I've always thought the ingredients for life were like some kind of cosmic secret, something incredibly rare that only happened here on Earth.
Right, a complete accident.
Exactly. But what if the very complex molecules that we're made of are actually common, like pantry staples of the universe?
Well, that's exactly what we're going to get into. That idea really flips the script on the whole miracle of life thing, doesn't it?
It really does.
So in this deep dive, we're looking at some new findings that show one of life's most foundational building blocks is, surprisingly common out there. We're talking about tryptophan.
Ah, tryptophan, one of the 20 amino acids we need for proteins.
The very same. And from a research standpoint, it's a perfect target. It has this wonderfully rich spectral signature in the infrared, so if it's there, our instruments can see it.
Okay, so let's get into this interstellar discovery. This came from the Spitzer Space Observatory, right?
Mm-hmm. It detected tryptophan in the interstellar material of the Perseus molecular complex.
In deep space. I mean, my first thought is, shouldn't a molecule that complex be, frozen solid or just blasted apart by radiation?
That's what you'd think, and that's what makes this so fascinating. The researchers found 20 distinct emission lines that matched tryptophan exactly.
20, so there's no doubt.
No doubt. This is in a star-forming region called IC 348, which is about 1,000 light years away. It's definitive proof of complex organic chemistry happening in the very clouds that form new stars and planets.
And the temperature, that's the part that really got me. They found it at 280 Kelvin.
That's right.
That's, 7 degrees Celsius? That is not what I think of as deep space cold.
It's surprisingly temperate, isn't it? It suggests these building blocks are robust. They're just out there waiting for a planet to form.
Wow. And this isn't just happening 1,000 light years away. We have evidence right here in our own backyard, so to speak.
We do, and that's where the OSIRIS REx mission comes in. The samples from the asteroid Bennu provide that local, undeniable proof.
And the pristine nature of those samples is so important, right?
Yeah.
Because they were protected from any Earth contamination.
Absolutely. We can say with very high confidence that what we found on Bennu is truly extraterrestrial.
So what did we find in that little bit of asteroid dust?
We found almost a complete starter kit for life. 14 of the 20 protein-building amino acids.
14.
Yeah. And on top of that, all 5 nucleobases.
The building blocks of DNA and RNA.
The whole set. It really reinforces the idea that this chemistry was widespread across the early solar system. Now, of course, pulling those secrets out of a few grams of dust, that takes some serious analytical power.
Oh, I can imagine. Analyzing such incredibly complex data, whether it's from an asteroid or from across the galaxy, you need some cutting-edge tools.
You really do.
And, this deep dive is sponsored by Embersilk. If your business needs help turning complex data into real insights, Embersilk specializes in AI solutions for training, automation, and software development. They help uncover where AI agents could make the most impact for you. You can check them out at embersilk.com for your AI needs.
A perfect fit.
So let's connect the dots. We've got complex protein ingredients in distant nebulae and a whole organic toolkit delivered by an asteroid right here. What's the unified conclusion for you?
Well, the takeaway is just, it's hugely optimistic. It suggests the universe is chemically biased toward life.
Biased toward life. I love that.
Yeah. These essential ingredients aren't some rare fluke. They seem to be standard products of astrophysics that just naturally assemble. This totally changes how we should think about life on other worlds.
So less of a miracle.
And more of a cosmic inevitability. If you just add time and a little water.
Yeah.
That is an inspiring way to look at it. If these complex precursors are literally built into the fabric of star formation, it really makes you wonder, doesn't it? How many worlds out there are just waiting for the right conditions to start their own biological journey? If you enjoyed this deep dive, please subscribe to the show. Hey, leave us a 5-star review if you can. It really does help get the word out. Thanks for tuning in.